Example 3. Transform the Laplace equation del square u into spherical polar coordinates. Solution: let x equals to r sin theta cos of phi, y equals to r sin theta sin phi, z equals to r cos of theta. In spherical coordinates, u equals to u r theta phi, r square equals to x square plus y square plus z square, theta equals to tangent inverse square root of x square plus y square upon z, and phi equals to tangent inverse y upon x. Thus we have theta x equals to cos of theta cos of phi upon r, theta y equals to cos of theta sin phi upon r, theta z equals to minus sin theta upon r. Similarly, phi x equals to minus sin phi upon r sin theta, phi y equals to cos of phi upon r sin theta, and phi z equals to 0. U of x equals to u r sin theta cos of phi plus u theta cos of theta cos of phi upon r minus u phi sin phi upon r sin theta. Uy equals to u r sin theta sin phi plus u theta cos of theta sin phi upon r plus u phi cos of phi upon r sin theta. Uz equals to u r cos of theta minus u theta sin theta upon r. Uxx value is equation 1, which we have already done in part 2nd. Now the part 3rd, uyy equals to uy r ry plus uy theta theta y plus uy phi phi y equals to uy's value ur sin theta sin phi plus u theta cos of theta sin phi upon r plus u phi cos of phi upon r sin theta, and this whole term's partial derivative with respect to r into ry's value sin theta sin phi plus again uy's value same as it is, and this whole term's partial derivative with respect to theta and theta y's value cos of theta sin phi upon r plus again uy's value same as ur sin theta sin phi plus u theta cos of theta sin phi upon r plus u phi cos of phi upon r sin theta. This term is partial derivative with respect to y, and phi y's value cos phi r sin theta equals to sin square theta sin square phi urr plus ur theta cos of theta sin square phi sin theta upon r plus u theta sin theta sin square phi cos of theta minus 1 upon r square plus ur phi cos of phi upon r sin theta into sin theta sin phi plus u phi cos of phi upon sin theta into sin theta sin phi into 1 minus 1 upon r square plus ur theta sin phi into cos of theta sin phi upon r plus ur cos of theta sin phi into cos of theta sin phi upon r plus u theta theta cos of theta sin phi upon r into cos of theta cos of phi upon r plus u theta 1 upon r sin phi into cos of theta sin phi upon r into minus sin theta plus u phi theta cos of phi upon r sin theta into cos of theta sin phi upon r plus u phi cos of phi upon r minus 1 upon sine square theta into cos of theta sine phi upon r plus ur phi sine theta sine phi upon cos of phi upon r sine theta plus ur sine theta cos of phi upon r sine theta plus u theta phi cos of theta sine phi upon r into cos of phi upon r sine theta plus u theta up into 1 upon r into cos of theta into cos of phi into cos phi upon r sine theta plus u phi cos of phi upon r sine theta into cos of phi upon r sine theta plus u phi into 1 upon r sine theta into minus sine phi into cos of phi upon r sine theta equals to u r sine square phi plus u theta cos square theta sine square phi upon r square plus u phi cos square phi upon r square sine square theta plus u r theta into 2 sine theta cos of theta sine square phi upon r plus u r phi into 2 cos of phi sine of phi upon r plus u theta phi into 2 cos of theta cos of phi sine of phi upon r square sine of theta plus u r into cos square theta sine square phi upon r plus cos square phi upon r plus u theta minus 2 into sine theta cos of theta sine square phi upon r square plus cos of theta cos square phi upon r square sine theta plus u phi into minus sine phi cos of phi upon r square minus sine of phi cos of phi upon r square sine square theta minus cos of theta sine of phi into cos of phi into r square sine square theta equation 2. Similarly, uz equals to uz rz plus uz theta z plus uz phi z equals to ur cos of uz's value ur cos of theta minus u theta sine theta upon r, this whole term partial derivative with respect to r, and rz value cos theta plus again uz's value same as it is ur cos of theta minus u theta sine theta upon r, whole terms partial derivative with respect to theta into theta z's value minus sine theta upon r, and the third term is 0 as phi z's value is 0, so which is equals to u r cos square theta minus u r theta 2 sine theta cos theta upon r plus u theta sine square theta upon r square plus u r sine square theta upon r plus u theta cos of theta sine theta upon r square. This is equation 3. Adding equation 1, 2 and 3, we get uxx plus uyy plus uzz equals to urr plus 1 upon r square u theta plus 1 upon r square sine square theta into u phi plus 2r ur plus 2 upon r ur plus cos of theta upon r square sine of theta u theta equals to 0, or del square u equals to ur plus 1 upon r square into u theta plus 1 upon r square sine square theta into u phi plus 2 upon r ur plus cos of theta upon r square sine theta u theta equals to 0, which can be written as del square u equals to del upon del r into r square del u over del r plus 1 upon sine theta del over del theta of sine theta del u over del theta plus 1 upon sine square theta del square u over del phi square equals to 0. Hence proved.